minimizing some quantity, which we often call the objective function. And so there are many examples of sort of when this comes into play. So one example is if the social planner, which we might have be you in the context of the problem, the social planner would want to maximize the net benefits of an activity. So that's the difference between the benefits and the costs. A firm is interested in maximizing either its profits when it's deciding how much it should be producing, or potentially in minimizing the costs when it's deciding sort of what combination of inputs it should be using to produce a given level of output. Consumers, of course, are interested in maximizing utility, and they have these utility functions that we can't generally observe, but we can sort of write down in theoretical terms. And so maximization is something that you have to be able to know how to do in order to solve all of these problems. The most difficult part, to be honest, I think, is usually defining the objective function. So defining what it is that you're trying to maximize and being able to just write that down in algebraic terms. Because once you've defined the objective function, then all you have to do is basically take a derivative with respect to the choice variable, which is the variable that either the social planner can control or the firm can control or the consumer gets to choose. And then it's just simple, like first semester, first year calculus from high school or something. Like you just take the derivative, set it equal to 0, and do a little bit of algebra to figure out what the solution is. But in order to do that, you have to define the objective function. And figuring out the objective function often means going sort of between like the words in the question to an actual mathematical equation. So there are two common scenarios that involve maximization, particularly in this class. And they're slightly different from each other. So you always want to keep that in mind and make sure you are aware of which one you're trying to do. So the first scenario basically involves finding an equilibrium. And the idea here is that we want to try to solve for what will happen. So like the question would be worded in a way like, for example, how much of a good will someone consume in this scenario, or how much of a good will a firm produce in this scenario, or how much of it will be supplied in equilibrium. So this is sort of like, let's just let the market operate and let's see what happens in terms of how much people buy or how much the firm is selling. The second scenario, though, involves solving for an efficient allocation. So here, what we are trying to do, or what the firm, so here what we're trying to do is basically try to solve for what should happen. So now we're thinking more in terms of being like the social planner who wants to try to maximize net benefits or try to come up with like an efficient allocation. And so we want to figure out what it is, like what the allocation is that we actually want to happen. So this would be like how much of a good should somebody consume, or what is the level of corrective tax that we should impose. And in some cases, like if there's no externalities and there's no monopolies and no other market failures and so forth, then the answer to these two questions might be identical. So finding the equilibrium of what will happen in just sort of a private market transaction with no interference by the government or any other third parties, that might in fact be the efficient allocation that you want. But once you introduce market failures, and particularly in this class like externalities, then the efficient allocation that we would like to happen is not necessarily the equilibrium that will happen without any intervention. Okay, so the most difficult problem, as I said, is usually setting up the maximization problem itself. Once that's defined, then you just have to do differentiation and algebra. So there's really two key steps here when you set up the problem. First, you want to determine what it is that you actually want to maximize. So it might be utility if you're looking at the consumer's problem. It might be profits if you're looking at the firm's problem. It might be net benefits if you're looking at the social planner's problem, where net benefits would include both the social benefits and the private benefits. So you need to then so you need to determine what it is that you want to maximize. This is basically saying what is the objective function, what's the quantity you're actually trying to maximize. And then the other key step is figuring out what your choice variables are. So what are you maximizing with respect to? And so really the key here is figuring out like what's a choice variable and what's just a parameter. So a parameter is basically something that's taken by the person who's solving the maximization problem as given. So for example, like a firm operating in a perfectly competitive environment where it's not a monopoly and it's not a monopsony would take prices as being a parameter, right? The price isn't something the firm can choose or affect. However, the quantity produced would be a choice variable because that's something where the firm gets to choose how much it gets to produce. So I just want to illustrate the technique using an example. Let's suppose that we're trying to determine the quote-unquote efficient level of pollution from the Richmond refineries. And there are really two questions that you want to know. First, you want to know how much the refineries are going to emit in the absence of any intervention. And then you'd like to know how much would we like to, or would we want to allow the refineries to emit after we account for the social costs of pollution. So of course, in order to answer these questions, we have to make a series of assumptions. And basically, I need to actually give you cost functions and benefit functions and so forth. So we make assumptions to set up a tractable problem. First of all, we're going to assume that the refineries are price takers. So they can sell the refined oil on the market at a price of $P per barrel. We're going to also assume that they have convex total cost curves. So the marginal cost is going to increase with output. So we're going to say total cost is equal to 1,000 plus C1Q plus C2Q squared. So Q there, the quantity, is how much is being produced, and then C1 and C2 are parameters of the problem. And emissions are going to impact the health of local residents. So there's also health costs that are involved here. And we're, again, going to assume that the marginal impact increases with emissions. So the health costs are going to be C3Q plus C4Q squared. So C1, C2, C3, and C4 are all assumed to be positive here. So you have, as you increase the quantity, the total cost of production, of course, goes up. And then also these associated health costs go up. So in your groups, I just want you guys to talk for a couple minutes and write down the expressions for both the total refinery profits, given the setup that I gave you, and also the total net benefits to the refinery and the residents. So the key here, again, is you need to think about like what's the problem that's trying to be solved and what are the variables that are the choice variables. So just do that, and like I'll just have one of the groups give its answer in a couple minutes. Okay, so I'm gonna, you guys have like, just wrap it up in 30 seconds or so, and then I'm gonna select a group. Okay, so group one, what was your answer for the first one, the total refinery profits? Mm-hmm. Yep. So the total cost was the whole thing. Yeah. Okay, so that's correct. And then when you have total net benefits, how does the expression change? Right. Yep. So then if you wanted the net benefits as a function of Q, you have PQ minus 1,000. So you're subtracting both TC and HC, but you could also maybe simplify a little bit by doing C1 plus C3 times Q, and then minus C2 plus C4 times Q squared. And so then in these expressions, which are your choice variables and which are your parameters? Mm-hmm. Right, the C1, C2, C3, C4, and then also P as well. So all of those are basically being given by either the market in the case of P, which is the market price of the refined oil, or you can think of sort of like technology in the case of C1, C2. Those are sort of like the cost of producing a given amount of oil, or they're determined by the cost parameters for producing a given amount of oil, which is determined by sort of the current technology that's available. And then C3 and C4, I mean, you can also view those as being quote unquote technology parameters. Those are more sort of like almost biological parameters of how people are hurt by air pollution. Okay. Yeah, so that's a good question. The short answer is yes, you do not need to consider that. And so the longer answer is that there's two things, there's two reasons why you wouldn't consider it. First of all, to the extent that they're just going to be paying, or the extent that the market price P represents like their willingness to pay, then that's already, yeah, so the marginal, right? So then the second, right, so you're going to like, well, but there's some people who have positive consumer surplus who like value it more than the market price, right? So that's also true, but the probability that they will be the ones buying the good is like zero almost, right? Because it's a good that's traded on a global market, right? So they'll produce the good in Richmond, but then it's very unlikely that like the people in Richmond will be buying the gasoline that's being produced in the Richmond refinery, right? It's basically being exported to other places. So now somebody of course will be getting consumer surplus. The reason why that, like, so if you want to take a global view and say like, well, I need to figure out like, what the global consumer surplus is, that would affect the total benefits, but it wouldn't actually end up affecting like the efficient level of production, because what's going to matter is basically the marginal value, like the marginal benefit and the marginal cost. And for the marginal person, P is actually capturing their marginal willingness to pay. Was there another question for that? Okay. Okay, so then once you have this function, it's pretty straightforward to solve for the efficient level. So I just to sort of put some numbers on the problem, I said let's assume the following. So we'll let the price be $80 per barrel. The cost parameters are C1 equals 40, C2 equals 0.01. So then the profit function turns out to be 80Q minus 1,000 minus 42 minus 0.01Q squared. You can differentiate that with respect to Q. You get the derivative, which is 80 minus 40 minus 0.02Q, and set that equal to 0. And what you'll get is a quantity of 2,000. So that's the amount of oil that's going to be produced in the private market equilibrium, where there's no interference or there's no intervention from the policymakers. So that's the profit maximizing quantity, but of course, that's not the quantity that maximizes the total net benefits to both refinery and Richmond, because there is this negative externality. So then we figure out the solution to maximizing the net benefits function, which is right here. So again, P, C1, C2 are the same, but now we have these health costs, which are represented by C3 equals 10 and C4 equals 0.05. So we plug in all of those parameters to this equation that we wrote up here, take the derivative with respect to Q, set that equal to 0, work through the algebra, and what you get is that the quantity now is 1,000. So that, in this particular case, happens to be half the profit maximizing level of production. So the quantity that maximizes the net benefit is 1,000 barrels. And then you need to set the corrective tax to solve the problem. Ultimately, you have to set the corrective tax to be equal to the social cost of pollution. So you could set the tax equal to the social cost, the health cost function that we had up here, which was the C3Q plus C4Q squared. And once you do that, then if you solve through, you would find that the firm would maximize that net benefit function and actually produce 1,000 barrels of oil instead of producing 2,000 barrels of oil. So that's how you solve these maximization problems for the efficient level of output or the efficient allocation.